Mathematical logic is a fundamental branch of mathematics. It deals with the study of reasoning and argumentation. It provides a formal framework for analyzing and evaluating the validity of arguments, ensuring that conclusions logically follow from the given premises. Symbolic arguments is a key component of mathematical logic. It employs symbols to represent logical statements and operators to represent relationships between them. This allows for a clear and concise representation of arguments, facilitating rigorous analysis and the construction of sound proofs.
We will now discuss about symbolic argument. Symbolic argument is a set of statements expressed using symbols where one statement is designated as the conclusion, and the remaining statements are called premises. The validity of a symbolic argument depends on the logical relationship between the premises and the conclusion. An argument is considered valid if the conclusion must be true whenever all the premises are true. In contrary, an argument is invalid if it is possible for all the premises to be true while the conclusion is false.
So now let's move to the characteristic of symbolic arguments. First is we have precision. As symbolic arguments allow for precise representation of logical relationships, avoiding the potential for misinterpretation inherent in natural language. This precision is crucial for constructing rigorous proofs and ensuring the soundness of logical deductions. So next we have abstraction. These symbolic arguments abstract away from the specific content of statements, focusing solely on their logical structures. These abstractions enables the analysis of arguments regardless of their subject matter, facilitating the application of logical principles across the diverse domain. So next we have deductive reasoning. These symbolic arguments rely on deductive reasoning where conclusions are derived from premises through a series of logically valid steps. This deductive process ensures that the truth of the premises guarantees the truth of conclusions, forming the foundation of mathematical. So the last one is formalization. These symbolic arguments utilize a standardized system of symbols and operators to represent logical statements and relationships. This formalizations eliminates ambiguity and ensures consistency in the analysis of arguments.
To further understand about symbolic arguments, let us discuss about it more by giving and illustrating examples. I have an examples here about symbolic arguments. For our example 1, it has premises 1 and 2. The premise 1 here is that if it rains, then the ground will be wet. So the premise 2 is that it is raining. Conclusion, therefore, the ground is wet. For our example 2, we also have 2 premises. The premise 1 is that if you study hard, then you will get good grades. If you study hard represents the P, and then having good grades represents the Q. Premise 2. If you get good grades, then you'll get into good college. The conclusion here is that, therefore, if you study hard, then you will get into good college. Last one, example 3. It also has 2 premises. The premise 1 is, if it's weekday, then I go to work. The weekday here represents the P, and going to work represents the Q. Premise 2, I am not at work. That is negative Q. The conclusion, Therefore, it's not weekday. It represents the negative P also. Understood?
These rules of inference are fundamental building blocks in logic, allowing us to derive new conclusions from existing statements. They are used in various fields including mathematics, computer science, and philosophy to construct valid arguments and proofs.
Rules of inference are logical principles that govern how we can deduce new information from a set of given statements. They are like templates for constructing valid arguments, ensuring that the conclusion follows logically from the premises.
Knowing mathematics, they underpin rigorous proofs, ensuring that each step follows logically, while in computer science, they drive decision-making within algorithms and programming logic. While in philosophy, rules of inference help clarify arguments and assess the soundness of claims, promoting critical thinking and enhancing the reliability of their conclusions. There are four types of key terminologies under rules of inference. The first one is the premise. It is a statement assumed to be true. The next one is the valid argument. It is an argument where the conclusion logically follows from the premises.
The next one is conclusion. Conclusion, a statement derived from the premises using rules of inference. And lastly, sound argument. Sound argument, a valid argument where all premises are true.
Let's explore the four rules of inference. The first one is modus ponens, or rule of detachment. Rules of inference: premise 1 is P, premise 2 is P and Q, and conclusion is Q. If we know that P is true and that P implies Q, then we can conclude that Q is true. This rule is often used to establish a consequence based on a known condition. Example, premise 1, it is raining and P. Premise 2, if it is raining, then the ground is wet, P and Q. And conclusion, the ground is wet and Q.
The next rule of inference is the law of syllogism. Rules of inference is premise 1, P and Q, premise 2 is Q and R, conclusion is P to R. If we know that P implies Q and Q implies R, then we can conclude that P implies R. These rules us to chain together conditional statements to reach a more distant conclusions. An example of the law of syllogism is premise 1, if it is snowing, then the roads are slippery. The premise 2 is, if the roads are slippery, then driving is dangerous. So in conclusion, if it is snowing, then driving is dangerous.
And the third one is modus tollens. Rules of inference: premise 1 is P and Q, premise 2 is P, and conclusion is P. If we know that P implies Q and that Q is a false, that we can conclude that P is false. These rules used to disprove a hypothesis by showing that its expected consequence did not occur. So for example, premise 1, if you are a citizen of the United States, that you are eligible to vote, P and Q. And premise 2 is you are not eligible to vote. And conclusion is you are not a citizen of the United States.
The last rule is the rule of disjunction syllogism. The rules of inference is the premise 1 is P and Q, premise 2 is P, and the conclusion is Q. If we know that either P or Q is true and that P is false, then we can conclude that Q is true. This rule allows us to eliminate one possibility from the disjunction statement to determine the remaining truth. So an example of this is the premise 1 is you are either at home or at the library. The premise 2 is you are not at home. And the conclusion is you are not at the library. Therefore, these four rules of inference are essential tools for logical reasoning. They provide a framework for constructing valid arguments and deriving new conclusions from existing knowledge. By understanding these rules, we can enhance our critical thinking skills and make more informed decisions.
In conclusion, symbolic arguments play a crucial role in mathematical logic, providing a powerful tool for analyzing and evaluating the validity of arguments. By employing a formal system of symbols and operators, these arguments ensure precision, clarity, and abstraction, facilitating the construction of rigorous proofs and the exploration of complex logical relationships. Understanding symbolic arguments is essential for anyone seeking to delve deeper into the world of the mathematical logic and its application in the various fields.